So the typical coordinate system that we use, when we did sine, cosine, is what we call the Cartesian or rectangular coordinate system. Rectangular because y is the specific case of the rectangle. Rectangle is the most general. So in the rectangular coordinate system, we have a point P, and we call the point P as x, y. Do you agree? So you simply end up saying, I'm taking x steps along the x-axis, perhaps somewhere over here. Yes. Y steps along the y-axis. There. And then you put the point P. Do we agree? That's the regular Cartesian coordinate system. When they say polar, what comes to your mind? Polar opposites. Okay, so go ahead.
The opposite. It's just like chemistry polar.
Okay, chemistry polar. What is it, Barry? Go ahead. When we think of polar, what comes to your mind? Well, polar bears. But why are polar bears called polar bears? The poles, right? What's called the South Pole. Now, if you tell, well, I hope you all believe in the fact that Earth is not flat. If so, if you believe that it is, drop out of college to go do something else. So the Earth is a sphere, right? It's called North Pole, South Pole. And everything that we define is based on, well, cross sections of a sphere, which is so polar coordinate function relative to a pole, and think of a sphere. If you took cross section of the sphere, you will be looking at circles. So in polar coordinates, we are looking at circles rather than rectangles. Again, rectangular coordinate system. Special case is squared. This is my very poorly drawn attempt to demonstrate something. What does that remind you of?
A grid.
Huh?
A grid.
A grid. Okay. Wonderful example, grid mesh, but simpler than that. Some sort of paper. Graph paper, right? So graph paper that you look at is always in that form. Now do you see why we call it rectangular coordinate system? Rectangular, hangable squares. Polar, pole 1, pole 2, pole 3, pole 4. Yes, macro perspective as to which is northern and south. With polar system, we're not going to look at squares, if that's it. Rather, my very poorly drawn attempt at polar system. But it will get the point of this, I guess. Good. We have seen this before. One. The unit circle has a radius of 1, right? But then I mentioned, well, if you go from a unit circle and if you increase the radius, no matter what the radius is, the angle that you form will be exactly the same. You're just jumping from one circle. It's really bad. But the point I'm trying to make, the R-axis would denote the radius. I want you to seriously assume that all of these are perfectly drawn circles. Good. So, circle of radius, say 1. Circle of radius 2. Yes. Circle of radius 3. Circle of radius 4, and so on, right? So if you have a graph paper that's got a bunch of circles, separated by unit radii, then you have a polar system. So I have covered one crucial bit or one coordinate of a polar coordinate system, which is the radius. Agreed? The radius is just like the x-axis. It tells you where a point is going to be at. Great. What do we need in addition to x in Cartesian system? What Cartesian system? In addition to x, you need 1. So what would serve as 1 in the polar system? The angle, enlightenment, what do you mean by that?
Direction.
So if I arbitrarily place a point on the third circle of radius, that particular point has a radius of 3. Yes. And it is at a specific angle from the reference axis. Yes, rotating. So I can say that that point is based on 2 things. One, radius. The other, the angle theta. So a point in the rectangular system is x, y. The point in the polar system is r, theta. So if I want to represent the position of an airplane relative to a tower down at RSW, I am not going to use the XY system. Why? XY system, why? Do you follow my question? If I want to look at the position of a airplane relative to air traffic control tower down at RSW, I am not going to use the XY coordinate system. I'm going to use the polar system. Why? Can't hear you, bro. Different heights, okay. Nolan, did you have something to say? Kind of, but no, what was the kind of answer?
So it's gonna be. Never mind. Like, I don't even want to say it.
Okay.
That's why doesn't account for that.
So
Like,
So XY doesn't account for what you say. The shape of the earth, for instance. When we say XY, well, if I want to look at a point here, XY system is amazing, rectangular, easy. But if I want to get to space, and space has a third dimension, and you want to do the XY, then you have to draw the triangle, right-handed triangle, look at the height of that, but we did a problem like this earlier. So too much work, but it is convenient for me to say R, theta. Yes. Now, you might have seen movies. Have we seen the movie Independence Day in the 90s? Yes, they made a remake, which was a flop. Yes. So one of the scenes in that movie is a radar. Yes, that constantly keep track of these alien ships, right? Beep, beep, beep. So that radar is in full coordinates, right? Different radii, and you measure the angle at which the object is at. So army, navy, submarines, all that stuff. That's just these full coordinates. In maths, you get to draw fun curves such as the lemniscate and others. Are we clear? Yes. So in the rectangular system, we have x and y. In the polar system, we have a point R common easily, but there is always a connection between the two. So I can hop from rectangular to polar, polar to rectangular, easily. Any points? Only in 2 dimensions. This class, no thanks to any points? I have mentioned this once before. I didn't use the word polar coordinate, but we did do this. Use the word polar coordinates. What type of triangle is right triangle? White triangle. Okay. Again, assume that these are nicely drawn circles. Good. So that is an angle. Yes. That point is at a radius R, arbitrary radius. At an angle theta with me. Agreed. Okay. In the rectangular system, that height is denoted by the letter Y. That length over there is denoted by the letter X. And if I asked you, well, how do you write X in terms of R and theta? What would you say? Okay, thank you. X is equal to R cosine theta. Enlighten us, okay? That is not very smart. Think. My cat can memorize it all and hand it back to me.
Oh,
every time it
so
turns up.
that's the X coordinate is cosine. Yeah.
But why? Using that picture.
Okay, so it's gonna be cosine sine, so X cosine theta will give you the X coordinates, and then like y sine theta, or X sine theta will be the y coordinate.
Okay. You just memorized it. You didn't think. X would be R cosine theta. Y will be R sine theta. I want to know why using that triangle, assuming nice little circles.
Because for sine, it would be between the y, because the opposite of theta is the side that is defined by y.
And then it's over hypotenuse, and the hypotenuse is R, so it cancels. And then R cosine theta is the same logic, except it's adjacent to the side that's defined by X.
Very good. So it goes back to the triangle. Opposite divided by hypotenuse is sine. Adjacent divided by hypotenuse is cosine. Adjacent x. Hypotenuse is simply the radius r multiplied by r on both sides. You get that. Yes. Sine theta y divided by r. Yes. Opposite over hypotenuse. You get that. So, if you understand something, don't have to know. It's my principle, my fundamental principle of learning. You understand something, you don't have to memorize anything. It applies to everything in the field. So, if I know an R value and theta value, I can connect it directly to an X value and Y value in the rectangular system using that. If I know the X value and Y value here, I can connect it directly to R and theta. Which coordinate system to use is a matter of the application that you are looking at. I gave you an example of that. I would not find using the metric system if not this. The Cartesian system to be the first system to go with if I want to determine the location of an object. Yes, my go-to would be Euler, and if I wanted to convert, I can convert it to a rectangular system. But what is my go-to? If I want to measure the dimensions of this floor, I'm not going to go with Euler system. That's silly. The floor is in the shape of a rectangle, more or less. Go to the target system. So which system to use is a matter of choice. You can always go between the two systems. Why are they called polar coordinates? Just like you said, think of polar bear as why polar, south pole, north pole. Yes. And Martin saying something. Rectangular system, tiny little squares. Here, properly drawn that line. Any question? Okay.